digital intellectual system for close, accurate reposition of bone fragments and their fixation using a massive rod, locked at 4 levels with angular stability screws. Here are shown methods which once committed a breakthrough in fracture management, and mostly due to the increase in strength, the fixation of fragments, and then a long stagnation. We have combined the best qualities of these methods into one whole. Initially created a device for drilling the medullary canal along a given radius, which would correspond to the natural curvature of the femur, or the bend of the cortical layer of the tibia and humerus. This allowed for the use of a significantly more powerful rod, and the usual blocking screws are replaced by blocking screws with an angular stability, which are now installed on 4 levels. This design can withstand the wound's full load, even with comminuted and oblique fractures, but installing such a rod is quite laborious, and we have developed a model of traumatologist robots for close accurate reposition and the osteosynthesis of fragments. The basis is 3 manipulators. First controls a model with 2 pairs of heads, each of which has 2 engines designed for longitudinal movement of the ramrod, which grabs and extends the tool from the magazine and back, for tool rotation, for longitudinal movement of the body, in which the spokes, scalpels, drills, and screwdrivers with locking screws are laid, and tool changes by turning the magazine. Second manipulator, the same for the proximal fragment. The third manipulator controls a multifunctional tool, in the width a store of, a scalpel, the same device for drilling the intraosseous canal along a given radius, and the intraosseous shaft with a bend along the same radius. After preliminary stretching, an X-ray control is performed. On monitors, the image of fragments obtained from visualizers is supplemented by data from a computer. The computer aligns the axis of the fragments and the intersection points of the tool exit axis of the tools by the first and second manipulators are set on the axis of each fragment, after which, through the metaphyses of fragments, automatically drawn, fixed, and stretched are threaded through spokes, one through each fragment, followed by distraction of first and second manipulators, until the removal of the fragments. Repeated X-ray control. Then the tool exit axis and the fragments axis are recombined, and then the fragments are drilled with 2 pairs of spokes, without overlapping, bone marrow canal tightly compressed due to the longitudinal and the angular movement of the tool and are precisely matched. Pass-through threaded spokes are automatically removed. The third manipulator is combined, multifunctional exit axis with the radius axis of the bone. Soft tissues are cut through to the bone with a scalpel. Then, with a drilling device along the given radius, the medullary canal is reamed, and the intraosseous shaft is inserted using a vibration machine. After the X-ray control, the exit axis of the instruments are adjusted, which were tuned before the operation. 8 scalpels are used to cut through the soft tissue. 8 drills simultaneously drill the transverse channels into the bones in 2 passes. The first drill passing through the threaded channels of the rod drills both cortical layers, and the second of a larger diameter, only the proximal cortical layer, after which 8 locking screws screwed into the screwdrivers are inserted into these channels and screwed into the shaft, and not into the bone, until they stop, as is customary until now, which ensures their angular stability. According to this technique, 6 operations have been successfully performed for complex fractures. Such fixation will exclude cases of non-union or delayed consolidation. The robot will also be able to perform osteosynthesis of the tibia and the humerus, and not only. In the case of joint replacement, strengthen both components of the endoprosthesis with blocking screws with angular stability. An order of magnitude to improve the quality of fixation of large defects of long bones and bone grafting, thereby making for the first time a real alternative to bilocal osteosynthesis. And finally, we get a long-term implementable limb prosthesis with the possibility of an early full load, which will save patients from lameness and stump receptors.
As an author, I know that the project is ready to be implemented. But now we need a person who could bring it to life. with my help, of course.